The two sides of a fair coin are labeled as 0 and 1. The coin is tossed two times independently. Let M and N denote the labels corresponding to the outcomes of these tosses. For a random variable x defined as x is equals to minimum of M and N, the expected value rounded off to 3 decimal places is. The NPTEL video reference for this question is Lecture 27 Probability Foundations for Electrical Engineers by Dr. Krishna Jagannathan, Department of Electrical Engineering, IT Madras. Some useful information in order to solve this question. Expectation value of a discrete random variable x is the product of the ith real value of the random variable times its probability and summed over all such i's. Let the random variable x take a value x1, x2 and x3 with probability p1, p2 and p3, then its expectation value is x1 times p1 plus x2 times p2 plus x3 times p3. For two tosses of the coin, there are 4 possible outcomes. Since the side of the coin is labeled as 0 and 1, the outcomes can be 0, 0, 0, 1, 1, 0 and 1, 1. Since M and N denotes the label on the first coin and second coin respectively, they can be written as. Since the coin tossing are independent of each other, hence all the 4 outcomes have equal probabilities of 1 by 4. The random variable x is the minimum of M and N. So the minimum of 0 and 0 is 0. Similarly, minimum of 0 and 1 is again 0. Minimum of 1 and 0 is 0. And the minimum of 1 and 1 is 1. The expectation value of x is xi times probability random variable x is equals to xi summed over all I. So it can be written from the above table by calculating the product of these two columns and taking their sum. Which is equals to 1 by 4 or 0.25. So the expected value of x rounded off to 3 decimal places is 0.25